Hello everyone, welcome to my channel Dhi Earth. Today we will explore how the future of clean energy is evolving. Today we are diving into the world of green hydrogen and its impact on the global energy transition. Let's begin with the types of hydrogen categorized based on their production processes. First, we'll look at the green hydrogen. Green hydrogen is the cleanest type. It is produced using electrolysis, where renewable sources like wind or solar power the splitting of water molecule into hydrogen and oxygen, generating zero emissions. Second is the blue hydrogen. Blue hydrogen is made from natural gas, but it has an added step, that is produced carbon dioxide is captured and it is stored through CCUS, which helps reduce CO2 emissions and making it a cleaner alternative to grey hydrogen. Now let's discuss what is grey hydrogen. Grey hydrogen is produced from natural gas through a process called steam methane reforming. However, this method releases significant amount of carbon dioxide, making it the most polluting type of hydrogen. Next is the pink hydrogen. Pink hydrogen is produced through electrolysis powered by nuclear energy, offering a low carbon alternative without relying on fossil fuels. Next is the yellow hydrogen. Yellow hydrogen is again one type of green hydrogen. It is produced from solar energy through electrolysis. It splits water molecules into hydrogen and oxygen. Now let's discuss about the use of hydrogen. So the first use is the industry sector. In the industry sector, hydrogen is crucial for refining, steel production and chemical manufacturing. It helps industries reduce carbon emissions. Another use is in the mobility sector, wherein hydrogen is used in fuel cells in the trucks, buses and trains for long distance travel, also heavy duty transport. Hydrogen powered aircraft are in development for zero emission flights, and ships are starting to replace heavy bunker fuels with cleaner hydrogen based alternatives. Here for the aircraft there is a challenge because hydrogen has low volumetric density and it requires more space to store it in the aircraft. So that is the biggest challenge. Next, use is as an energy carrier, and we know that hydrogen can also act as an energy carrier through green ammonia, and green ammonia is emerging as a hydrogen carrier for long distance transport and storage. Additionally, blending hydrogen with natural gas helps cut CO2 emissions, and burning hydrogen instead of coal or natural gas provides a cleaner energy source. Now we'll see what is the capacity forecasting of hydrogen by 2030 as per the International Energy Agency forecast. So this figure we have referred from IEA report, and we know that hydrogen is truly a versatile fuel for a sustainable future. And from this graph, if you see, by 2030 global hydrogen demand will still be dominated by traditional production methods like grey hydrogen, blue hydrogen, but the capacity for low carbon hydrogen is increasing. And when we look at the sector-wise hydrogen consumption, the industry and refining sectors will be the biggest user. So you can see here. So these are the biggest users by 2030, relying on hydrogen for processes like steel making, chemical production and refining. If you look at the region-wise graph, so the China and North America, it contributes around 45% of the global demand of hydrogen as of now. Now let's discuss what is the cost of hydrogen production. Let's look at the green hydrogen. Green hydrogen is the cleanest option we already discussed. It is produced through electrolysis using renewable energy and it costs around $3 to $7 per kg of hydrogen production, and its abatement potential is high, very high. Abatement potential means the ability to reduce carbon emissions during the production of hydrogen, and we know that green hydrogen production is a zero emission process, so that's why the abatement potential is very high. Next is the gray hydrogen. Gray hydrogen is made from steam methane reforming process without carbon capture, and this is the cheapest source of hydrogen. It costs around $1 to $2 per kg, but we know that it emits a lot of emissions, and that's why the abatement potential is low. Next is the blue hydrogen. It has a partial carbon capture, and it costs around $1.5 to $3.5 per kg and offers a moderate reduction in emissions. So this was about the type of hydrogen and their cost. We know that the reducing the cost of electrolysis technology and increasing renewable energy production will be key to making green hydrogen more competitive, because as of now the cost is in the range of $3 to $7, and government or the different companies are targeting it to reduce till $1 to $2 per kg by 2030. So that is the ambition. Now let's move on to a case study of British Petroleum. Let's look at how a major energy company, BP, is leading the transition to green hydrogen. British Petroleum has set a target to scale up green hydrogen production globally, and they have target to decarbonize industrial sectors such as refining and petrochemicals. We'll see key features of BP's green energy strategy. They have a plan to invest $36 billion in renewable, including hydrogen, by 2030. And the company is developing large-scale green hydrogen hubs in the UK, Australia, and Germany to accelerate adoption. To drive the transition, BP is forming partnerships with heavy industries such as refining and chemicals. They are also investing in electrolysis technology to lower the hydrogen production cost. There are key features, but there are challenges as well, and we also need to discuss the barriers of this transition plan. From our previous slides, we understood that green hydrogen production has very high capital cost in terms of investment, in terms of process management, technical and safety aspects, etc. And there are regulatory uncertainty and slow market adoption of this particular fuel. Hydrogen infrastructure requires massive investments, and policies are very across the countries, making large-scale implementation difficult for the companies. Despite these challenges, BP's goal is to scale up green hydrogen production and decarbonize industrial processes. This case study highlights the importance of corporate investments and innovation in making green hydrogen a reality. So this brings us to the end of this session on green hydrogen. And as we have seen, hydrogen plays a critical role in decarbonizing industries, transportation, and energy systems. For more insights on the future of clean energy, stay connected with Dhi Earth. Thank you for watching this session. See you soon.